Course 3, Industrial Processing, Operational and Financial Management in Food Processing, Economic Flexibility. Before we enter the technical content, this module focuses on operational and financial management in food processing, emphasizing the relationship between operational efficiency, cost control, and financial sustainability. Food processing enterprises operate under strict regulatory requirements, high resource use, and narrow margins, making efficiency and sound financial decision-making essential for competitiveness and resilience. The module introduces key concepts related to food production workflows, common sources of inefficiency, and practical tools for analyzing and improving operations. It also addresses startup finance in the food sector, exploring financing needs, funding options, and basic financial planning. Particular attention is given to economic flexibility and financial risk management, highlighting how efficient operations and waste reduction contribute to profitability, liquidity, and business resilience. Applied examples and practical exercises support learners in linking operational decisions with financial outcomes, promoting informed, data-driven management in food processing startups and small enterprises. The aim of this submodule is to explain how financial management and cost optimization strategies can be applied in food processing startups to use resources more efficiently without compromising food quality and safety. We will focus on how companies can control costs, respond to volatility in raw materials and energy, and build economic flexibility through better financial and operational decisions. The objective is to show that efficiency, resilience, and food safety can be managed together through structured planning and optimization practices. Recent empirical studies in agri-food supply chains demonstrate that firms with higher economic flexibility are significantly more capable of maintaining stable operations, protecting profitability, and continuing to meet quality and safety standards during periods of volatility, e.g., spikes in energy prices, shortages of raw materials, or sudden increases in logistics costs. Economic flexibility refers to the capacity of a food processing enterprise to adapt its financial and operational structure in response to external shocks, including fluctuations in input prices, disruptions in supply availability, volatility in demand, labor shortages, and changes in regulatory requirements. In the context of food manufacturing, where margins are typically narrow and the cost base is highly sensitive to resource consumption, economic flexibility is a fundamental driver of organizational resilience, continuity, and competitive performance. Economic flexibility therefore emerges as both a strategic capability and an operational safeguard in the increasingly uncertain environment of global food systems. Economic flexibility is multidimensional and encompasses several interrelated capabilities that influence financial performance, which are input cost adaptability, process and capacity flexibility, financial structure flexibility, and workforce and organizational flexibility. Food processors depend heavily on commodities such as grains, dairy, fruits, vegetables, oils, packaging materials, and energy, whose prices are among the most volatile globally. Research on cost variability in food manufacturing shows that volatility in input costs directly affects unit cost structure and can threaten both margins and liquidity. Economic flexibility in this dimension includes the ability to switch between suppliers, the capability to reformulate products using alternative ingredients, efficient inventory management to reduce exposure to price spikes, and the negotiation of flexible or long-term supply contracts. Studies conducted between 2021 and 2024 confirm that firms which diversify suppliers and maintain adaptable formulation strategies achieve stronger cost stability during market shocks. Process flexibility refers to the ability to adjust production schedules, batch sizes, processing speeds, and labor allocation in response to unexpected operational changes. In food processing, disruptions may result from equipment failures, seasonal variation in raw materials, changes in order volumes, and unexpected waste or rework. Firms with flexible processes can reassign labor, modify workflows, and shift between product lines, thereby reducing downtime and preventing excessive waste. Manufacturing research shows that flexible operations are associated with higher resilience and faster recovery following disruptions. Financial flexibility describes a firm's ability to mobilize financial resources when needed through access to credit, liquidity reserves, the capacity to adjust budgets, flexible cash flow management, and staged investments instead of rigid upfront capex commitments. Evidence from SME studies conducted during the COVID period and the post-crisis inflation phase demonstrates that firms with financial buffers and adaptive budgeting mechanisms were better able to withstand shocks such as sudden increases in energy prices or supply shortages. Labor availability is a recurrent challenge in the food industry, and economic flexibility also includes workforce adaptability. This involves having multi-skilled workers capable of performing different operational tasks, adaptable staffing schedules, and rapid training for new processes or equipment. Workforce flexibility reduces operational interruptions and supports steady productivity levels during periods of uncertainty. Economic flexibility is the foundation of resilience, understood as the ability of a firm to absorb, adapt to, and recover from shocks. Food processing enterprises operate in environments characterized by fluctuating raw material availability, rising and unstable energy prices, increasingly complex quality and safety standards, climate-induced variability in agricultural production, and supply chain disruptions intensified by global crises. Scientific research published between 2020 and 2025 consistently identifies economic flexibility as a key predictor of business survival and performance under volatile conditions, showing that companies able to adapt their cost structures, workflows, and patterns of resource use achieve stronger operational and financial stability. Economic flexibility is essential for resilience in food processing because it provides the capacity to absorb, adapt to, and recover from shocks without compromising operational continuity, product quality, or safety. Food processing enterprises operate in environments characterized by fluctuating raw material availability, rising and unstable energy prices, increasingly complex quality and safety standards, climate-induced variability in agricultural production, and supply chain disruptions intensified by global crises. Scientific research published between 2020 and 2025 consistently identifies economic flexibility as a key predictor of business survival and performance under volatile conditions, showing that companies capable of adjusting their cost structures, workflows, and resource use are better positioned to maintain stability and competitiveness. Beyond its operational implications, economic flexibility is increasingly recognized as a strategic asset. Firms that integrate flexible financial and operational systems are better positioned to innovate and test new products, adapt to regulatory changes, enter new markets, and attract investment by demonstrating stability and adaptability. Startups in particular benefit from flexible cost structures and adaptive operating models, as these reduce risk exposure and strengthen long-term viability. Economic flexibility is therefore a critical capability in food processing firms because it enables rapid adaptation to cost fluctuations, supply shortages, and operational disruptions, conditions that are becoming more frequent. Through flexible operational practices, structured financial planning, diversified supplier strategies, and workforce adaptability, food enterprises can enhance resilience, safeguard profitability, and maintain food quality and safety even under pressure. Cost optimization in food processing is not a matter of simply reducing expenditure. It involves using resources more efficiently while preserving product quality and ensuring compliance with safety standards. Scientific literature published in the last 5 years highlights that cost efficiency and food safety are compatible and mutually reinforcing when optimization strategies are well designed. Efficient use of energy, raw materials, labor, and equipment contributes directly to financial resilience, enabling startups to remain competitive even during periods of economic stress, price volatility, or supply chain disruption. Cost optimization must therefore be approached as a systemic effort, focusing on improving processes, stabilizing operations, reducing variability, and preventing waste, all measures that lower operating costs without compromising safety or quality. In this slide, we introduce the concept of economic flexibility and why it is so important in food processing operations. The key idea is that flexibility is not only an operational feature, but also a strategic and financial capability. Food businesses operate in highly volatile environments, with changing input costs, supply risks, and regulatory pressure. Economic flexibility allows firms to adapt their cost structures, processes, and financial decisions in response to these changes while still protecting product quality and safety. We will now look at the main dimensions of economic flexibility and how they support resilience, competitiveness, and long-term viability in food processing startups. Energy is one of the highest operational expenses in food processing, especially in thermal operations such as heating, cooling, pasteurization, and drying, as well as in cold storage. Evidence-based approaches to energy optimization include optimizing heating and cooling cycles to avoid overprocessing or idle running, implementing heat recovery systems where residual heat from cooking or pasteurization is reused, improving insulation and maintenance of refrigeration and steam systems, and applying load scheduling to align energy-intensive tasks with off-peak hours. Automated control systems are also used to maintain stable temperatures and reduce fluctuations. These measures contribute to financial resilience by reducing overhead costs, OPEX, and increasing margin stability, lowering exposure to energy price spikes, and improving process stability, which in turn reduces microbial or quality deviations. Yield improvement focuses on maximizing the proportion of raw materials that are converted into saleable product. According to multiple recent studies, improving yield is one of the highest impact cost optimization strategies in food processing because raw materials often represent between 50 and 80% of total production costs. Evidence-based techniques include improving cutting, trimming, or slicing precision in sectors such as meat, vegetables, and bakery, calibrating dosing or filling equipment to reduce overfilling or giveaway, monitoring raw material quality to adjust processing parameters in real time, reducing cooking losses through optimized thermal profiles, and optimizing mixing and emulsification to ensure uniform product structure. The financial and safety implications include lower raw material costs per unit produced, less rework, which reduces labor, energy, and sanitation cycles, more consistent product composition that supports quality compliance, and reduced batch variability, which lowers the probability of quality or safety deviations. Yield optimization therefore strengthens both cost competitiveness and product reliability. Waste in food processing includes offcuts, trimming losses, expired inventory, rework, spillage, out-of-spec product and packaging waste, and reducing it is one of the most widely studied sustainability and cost control strategies in food systems. Evidence-based approaches include the use of lean tools such as 5S, value stream mapping, VSM, and SMED to eliminate unnecessary movement and weighting, improved cleaning and sanitation design to reduce product residues lost during CIP, enhanced scheduling to avoid idle time and aging of raw materials, the use of sensors and digital monitoring to detect deviations early, and the application of FIFO principles to reduce expiry and spoilage. The impact on financial resilience includes direct reduction in material, energy, and disposal costs, less variability in production performance, lower environmental fees and waste handling expenses, and better margins that strengthen liquidity. Crucially, waste minimization does not compromise safety. On the contrary, it typically improves hygiene, traceability, and batch control. Process stabilization aims to reduce variability in production by standardizing workflows, equipment parameters, and operator practices. Scientific research consistently shows that stable processes produce safer, higher quality products at lower cost. Key stabilization tools include standard operating procedures with clear parameters, preventive maintenance to reduce unplanned stoppages, statistical process control to detect deviations early, continuous flow principles to reduce waiting time and work in process, and operator training to reduce handling errors and inconsistencies. The financial benefits include fewer defects and therefore less rework and discard, lower equipment downtime which increases throughput, more predictable production that supports better planning and cash flow control, and reduced labor costs through more consistent operations. The quality and safety benefits include more stable thermal processing that improves microbial safety, reduced risk of cross-contamination through consistent procedures, and more reliable adherence to critical control points. Packaging and logistics represent significant cost components in food processing, and inefficiencies in either area can lead to waste, product damage, and reduced shelf life. Optimization approaches include designing packaging with improved barrier properties to extend shelf life, minimizing packaging material waste through more precise cutting and sealing processes, optimizing palletization and storage layouts to reduce handling damage, and improving cold chain management to reduce spoilage and product returns. The financial and resilience impact of these measures includes reduced losses from damaged, expired, or returned products, improved transport efficiency and lower logistics costs, as well as stronger customer satisfaction and greater reliability in fulfilling contractual obligations. Recent scientific work highlights the growing role of Industry 4.0 technologies in reducing costs and stabilizing food processes. Data-driven optimization approaches include the use of sensors to monitor temperature, viscosity, fill weight, or humidity, predictive maintenance algorithms to anticipate equipment failures, real-time traceability systems, and digital dashboards for monitoring energy use and yield performance. The benefits include earlier detection of inefficiencies, reduction in waste caused by process drift, improved decision-making in scheduling, maintenance and quality control, and stronger regulatory compliance. Evidence shows that startups adopting even low-cost digital tools can achieve measurable improvements in operational efficiency, traceability, and financial performance. Unlike in other industries, cost optimization in food processing must never compromise food safety. Scientific evidence shows that processes which reduce waste, variability, and inefficiency also tend to improve quality and safety outcomes. More accurate dosing reduces contamination risk associated with rework, stable thermal processes improve microbial lethality, reduced inventory lowers exposure to spoilage, and preventive maintenance reduces the likelihood of contamination resulting from equipment failure. Cost optimization is therefore not a threat to safety, but a strategic tool for producing safer food at lower cost. Strategies such as energy efficiency, yield improvement, waste reduction, process stabilization, packaging optimization, and digital monitoring strengthen both financial resilience and product safety. For food processing startups operating with limited resources and high exposure to volatility, these approaches are essential for long-term viability and competitiveness. Cost volatility refers to unpredictable fluctuations in the prices of raw materials, energy, packaging, and labor, which together form the core cost structure of a food processing enterprise. In recent years, global food systems have experienced unprecedented instability, driven by climate disruptions, geopolitical tensions, energy market fluctuations, and supply chain fragility. Scientific studies published between 2021 and 2025 show that food processors, particularly SMEs and startups, are disproportionately affected because they typically operate with limited financial buffers, high dependency on agricultural commodities, energy-intensive processes, short product shelf life, and narrow profit margins. Volatility in even a single cost category can significantly distort unit economics, reducing contribution margins, creating liquidity stress, and compromising the firm's ability to maintain stable production and consistent product quality. This slide introduces the three main types of cost volatility that most strongly affect unit economics in food processing operations. These are raw material price volatility, energy and utility volatility, and labor cost variability. Each of these cost categories behaves differently, but all of them directly influence unit cost, margins, and cash flow stability. Because food processing typically operates with narrow margins and high resource dependency, fluctuations in any of these areas can quickly create financial pressure. Understanding how these three volatility sources work is essential for designing mitigation strategies, improving cost control, and strengthening economic resilience in food startups and SMEs. Raw materials such as grains, oils, dairy, vegetables, and spices can account for 40 to 80% of total variable costs, which makes price spikes financially critical for food processing firms. Recent scientific studies show that climate-induced crop failures, global logistics disruptions, and input shortages have increased price variability across many key ingredients. The financial impacts include higher variable cost per unit and therefore reduced contribution margin, greater difficulty in forecasting cash flow needs, which increases the risk of liquidity shortages, and pressure to raise selling prices, which may reduce competitiveness. There is also a greater risk of waste, since expensive raw materials cannot be overused or discarded without significant financial loss. Startups with limited working capital are typically the first to experience operational instability under these conditions. Food processing relies heavily on energy-intensive activities, such as heating for cooking, pasteurization and sterilization, as well as cooling and freezing, compressed air systems, water heating, and ventilation. Energy price volatility since 2021 has had a significant financial impact on SMEs in the food sector. The consequences for unit economics include sudden increases in operating expenses, higher cost per batch or per unit produced, and lower flexibility in production scheduling due to the need to manage energy consumption more carefully. In some cases, firms may even need to reduce output to contain costs. When energy prices become highly unpredictable, financial planning becomes more complex and cash flow pressure increases. Labor shortages, wage inflation, and changes in labor regulations have created significant volatility in labor expenses, particularly in countries experiencing strong regulatory shifts. Food processing remains labor-intensive in many segments, which increases exposure to these fluctuations. The impacts include higher unit labor costs, increased overtime costs due to understaffing, and a greater risk of reduced productivity or increased operational errors. This situation also creates pressure to move toward automation earlier than originally planned. As a result, labor volatility increases both financial risk and operational risk for food processing startups and SMEs. Higher raw material or utility costs erode the contribution margin needed to cover fixed costs and generate profit. At the same time, liquidity pressure increases because cash flow cycles become tighter as cash outflows rise unpredictably. Working capital needs grow and financial buffers are depleted more rapidly. Operational stability is also reduced since unpredictable input costs lead to inconsistent production schedules, lower machine utilization, and increased waste caused by rushed or low-volume batches. In addition, pricing risk increases because startups often struggle to adjust prices quickly without losing customers, which can create temporary or prolonged financial deficits. This slide presents the main strategic approaches that food processing startups can use to mitigate cost volatility and stabilize their cost base during disruptions. The objective of these strategies is to protect unit economics and maintain margin and liquidity even when input prices fluctuate. The key approaches include supplier diversification to reduce dependency risk, structured contract and procurement strategies to improve price predictability, and product reformulation with ingredient flexibility to lower exposure to volatile inputs. Operational measures are also critical, including process adjustments and efficiency improvements that reduce resource consumption. In addition, inventory and working capital strategies help balance availability and cash, while energy management strategies reduce exposure to utility price volatility. Together, these measures form a practical framework for cost risk mitigation and financial resilience. Relying on a single supplier increases exposure to price shocks and supply shortages, whereas supplier diversification reduces dependency on one source, increases negotiation leverage, allows sourcing from regions with lower volatility, and decreases the risk of stockouts. Through these mechanisms, diversification strengthens financial and operational resilience at the same time. In parallel, procurement contracts can be structured to stabilize costs and improve predictability. These structures include fixed-price contracts that lock prices in the short term, volume contracts that ensure availability, indexed contracts that allow transparent cost adjustments, and forward purchasing when prices are temporarily low. Together, these procurement strategies support more accurate cash flow planning and reduce exposure to cost volatility. Product reformulation and ingredient flexibility are increasingly recognized as economic resilience strategies in food processing. Reformulation may involve replacing volatile ingredients with more stable alternatives, reducing reliance on imported inputs, using modular recipes that allow ingredient substitution, and optimizing formulations to reduce waste or energy usage. These approaches maintain product quality while reducing exposure to volatile markets and unstable input prices. In parallel, process adjustments and efficiency improvements reduce the impact of rising costs by lowering overall resource consumption. Typical adjustments include optimizing batch size to reduce energy and labor use, improving yield to decrease raw material dependency, enhancing process control to avoid rework, and improving sanitation schedules to reduce water and chemical costs. Through these measures, improved operational efficiency functions as a buffer against external cost volatility. Inventory and working capital strategies are key tools for mitigating cost volatility and require structured inventory management. Effective approaches include maintaining safety stock of critical inputs, avoiding excess inventory to protect liquidity, timing purchases when prices are favorable, and using FIFO systems to prevent expiration losses. The goal is to balance cost, availability, and cash flow while ensuring production continuity. Energy management also plays a central role in reducing exposure to price volatility through monitoring systems, optimized heating and cooling cycles, renewable energy options, and shifting energy-intensive tasks to off-peak periods. These measures reduce OPEX and improve cost predictability. Overall, volatility in raw material, energy, and labor costs strongly affects unit economics in food startups with thin margins and limited buffers. Strategies such as supplier diversification, structured procurement, product reformulation, process optimization, and strategic inventory management help stabilize costs, preserve liquidity, and strengthen resilience under unstable market conditions. Organizational resilience in food processing startups refers to the ability to withstand disruptions, adapt to changing conditions, and sustain profitable operations despite uncertainty. Scientific literature published between 2020 and 2025 consistently identifies flexibility as one of the core determinants of resilience, especially in sectors exposed to volatile costs, supply chain instability, and high compliance requirements such as food manufacturing. Flexible management systems, both operational and financial, allow startups to respond rapidly to disruptions, minimize losses, protect product quality, and maintain operational continuity. In contrast to rigid structures, which increase vulnerability, flexibility provides the structural capacity to absorb shocks and reorganize activities without compromising safety, reliability, or profitability. This slide summarizes the main dimensions of flexibility in operational and financial management that support resilience in food processing startups. Flexibility must be built into both financial control systems and day-to-day operational decisions. On the financial side, budgeting flexibility allows companies to adjust spending and priorities when conditions change. On the operational side, flexible resource allocation ensures that labor, equipment, and materials can be reassigned quickly when disruptions occur. Production planning flexibility makes it possible to adapt schedules and batch structures without compromising quality or safety, while flexible investment decisions reduce financial exposure by staging or adjusting capital commitments. Together, these four dimensions form a practical flexibility framework that strengthens stability, responsiveness, and profitability under volatile conditions. A flexible budgeting system allows a startup to reallocate funds quickly in response to unexpected events such as spikes in raw material prices, equipment failures requiring urgent repairs, sudden increases in demand, and regulatory changes that require new compliance investments. Key characteristics of flexible budgeting include rolling budgets that are updated frequently, scenario-based budgeting using best, base, and worst-case projections, contingency reserves for unexpected costs, and dynamic adjustments to spending priorities. This type of budgeting enhances organizational resilience because it helps prevent liquidity crises by anticipating financial stress, enables rapid responses to cost volatility, and supports informed decision-making under uncertainty. Studies show that SMEs using flexible budgets recover faster from disruptions and maintain more stable financial performance over time. Flexible resource allocation refers to the efficient and adaptive use of labor, equipment, and materials in order to respond effectively to operational disruptions. This includes practices such as using multi-skilled workers who can cover different process steps, applying dynamic scheduling based on real-time demand, enabling cross-utilization of equipment for multiple product types, and carrying out emergency reallocation of materials to avoid spoilage. These forms of flexibility strengthen resilience by reducing downtime caused by shortages or absenteeism, increasing the capacity to maintain output during disruptions, and decreasing waste while improving overall efficiency. Research shows that flexible labor and equipment planning increases organizational responsiveness and reduces operational bottlenecks. Production planning flexibility enables companies to adapt production schedules, batch sizes, and workflows without compromising quality or safety. It includes the ability to scale production up or down, perform rapid changeovers between product types, adjust batch sizes during ingredient shortages, resequence production based on raw material availability, and split or combine batches to optimize energy use. This flexibility contributes to organizational resilience by maintaining operational continuity when supplies, demand, or labor fluctuate, preventing overproduction and reducing waste, and stabilizing resource consumption and overall cost structure. Scientific studies link production flexibility to reduced vulnerability during supply chain disruptions and to improved customer service reliability. Flexible investment decisions are essential in uncertain environments because investment strategies must adapt dynamically to changing risks and opportunities. Flexible investment systems are characterized by staged or modular investments instead of large upfront capex commitments, leasing or renting equipment to reduce financial exposure, prioritizing investments with rapid paybacks such as energy efficiency or yield improvement, and delaying or accelerating investments depending on market conditions. These approaches strengthen resilience by reducing financial risk during volatile periods, preserving liquidity by avoiding unnecessary fixed costs, allowing startups to adopt new technologies incrementally, and increasing investor confidence, through prudent capital allocation. Flexible investment strategies are especially important for startups with limited cash reserves. Flexibility is not only a technical or administrative concept, it directly supports economic survival and long-term competitiveness. Flexible systems allow companies to quickly reconfigure operations in response to raw material shortages, equipment breakdowns, staffing issues, market demand shifts, and quality deviations that require reprocessing. This ability to adapt reduces downtime and prevents cascading failures that would otherwise compromise production. Flexibility also increases continuity of operations, since resilient startups are able to maintain steady output even during instability by using rapid rescheduling, alternative sourcing, reallocating labor or equipment, adjusting batch sizes, and temporarily scaling production. Continuity is essential for meeting retailer contracts, maintaining shelf presence, and protecting brand reliability. Profitability is also strengthened because flexibility reduces waste and unplanned costs, improves resource efficiency, stabilizes unit economics under volatile conditions, and supports better decision-making and risk prioritization. Startups that can dynamically modify their cost structure are therefore more likely to maintain acceptable margins and avoid liquidity crises. Early-stage food processing ventures face higher risk because they typically operate with limited financial buffers and greater operational fragility. Flexible management systems help startups grow sustainably rather than overexpand, remain competitive even with limited resources, build investor confidence through robust risk management, and align financial and operational decisions in a strategic way. Flexibility, therefore, becomes a core capability of entrepreneurial resilience, supporting long-term survival and stable performance. Flexible budgeting, resource allocation, production planning, and investment strategies strengthen resilience by enabling rapid adaptation to disruptions, maintaining operational continuity, and preserving profitability. Together, these capabilities reduce vulnerability to cost volatility, supply chain shocks, and operational instability, making economic flexibility a cornerstone of sustainable performance in the food processing sector. Pricing plays a central role in food processing startups because it is essential for sustaining margins in environments characterized by volatile input costs. Food processors typically operate with narrow margins and limited pricing power, particularly when selling into retail channels, which makes pricing decisions strategically important. Effective pricing strategies support liquidity, protect contribution margins, and help maintain operational continuity. Pricing must respond to multiple sources of pressure, including raw material price inflation, increases in energy and utility costs, labor cost adjustments, fluctuations in logistics and packaging costs, demand variability and seasonality, as well as retailer-driven pricing constraints. If these pressures are not actively managed, they create significant exposure in contribution margins and weaken financial stability. Pricing in food processing must respond to volatility arising from multiple sources, including raw material price inflation, increases in energy and utility costs, labor cost adjustments, fluctuations in logistics and packaging costs, demand variability and seasonality, and retailer-driven pricing constraints. When these pressures are not actively managed through adaptive pricing strategies, they create significant exposure in contribution margins and increase financial risk for the firm. Food markets frequently display pricing rigidity, meaning that prices cannot be adjusted quickly even when costs increase. This rigidity is driven by retailer resistance to upward price revisions, contractual fixed price periods, consumer sensitivity to price changes, low bargaining power for startups, and strong competitive pressures in commoditized product categories. As a result, the pass-through of cost increases to selling prices is often delayed, which increases financial stress and compresses margins. Pricing also does not operate in isolation, but interacts closely with reformulation and procurement strategies. Ingredient substitution and reformulation, supplier diversification, and specification adjustments that reduce reliance on volatile inputs all support pricing decisions by protecting margins without compromising product quality or safety. Contractual and procurement mechanisms can enhance pricing flexibility and reduce rigidity in food markets. Firms may use flexible pricing contracts with review clauses, index-linked adjustments, hedging for key inputs, and negotiated pass-through mechanisms to transfer variable cost changes into selling prices more quickly. Adaptive pricing supports economic resilience by stabilizing margins, reducing liquidity stress, improving cash flow predictability, and increasing recovery capacity during volatility. In food processing startups with limited bargaining power, pricing becomes a strategic flexibility mechanism rather than a purely commercial tool, enabling firms to absorb shocks, protect margins, and preserve liquidity while maintaining production continuity and product integrity. Thank you.